Welcome, my name is Miguel and I am one of the authors of the paper Hybrid Models Everywhere. This paper has been presented at the workshop Social Media Mining for Health Application 22, and in particular we are going to deal with task 10 of this challenge, the SocialDisNER. So what is SocialDisNER? It is the given name to the task in charge of the automatic recognition of medical entities in Spanish tweets. As we can see in the image, a total of 10,000 gold standard tweets have been used for this task, in which all entities related to diseases have been tagged by hand. The goal of the participants of this task is the automatic prediction of these entities in unseen tweets. Our team has decided to treat this challenge as a medical entity detection problem using a methodology based on token classification. Therefore, we have developed a solution based on a hybrid system that mixes a transformers model with a rule system based on a medical ontology. The core of our architecture is based on the transformers model, while the rule system has been developed as a complement. In particular, we have decided to use the XLM Roberta-based model, as we have seen that part of the dataset was annotated in both Spanish and English. Our system has followed this methodology. First, we have pre-processed the training dataset to add the IOB notation. Once we finish this step, we have fine-tuned the base model to adapt it to the token classification task. And finally, noticing that some rare diseases were missed by our model, as we have never seen them in training, we devised a module in charge of the annotation of these diseases, thanks to space utilities and UMLS T047 annotations. The technical details of the fine-tuning of our model are as follows. Only we would like to emphasize that for this task the model reached convergence after 5 epochs with a batch size of 32, while for the other task of the challenge that we have participated, the number of epochs needed was the double. Regarding the dataset, we are dealing with a small corpus, with only 5,000 tweets for training. On the other hand, the test contained a total of 23,000 tweets, of which only 2,000 have been used to evaluate the approaches of the participants. At the same time, it is important to highlight that the official metrics of the task were strict accuracy, coverage, and F1. That for the initial validation stage, overlapping metrics were used, allowing participants to have more data for model performance analysis. Our analysis of the quality of the dataset has revealed a few flaws. On the one hand, we have found diseases that were used with a metaphorical meaning being annotated as a disease when they should not be. On the other hand, we have seen diseases in English annotated, even though this is a task for Spanish. And finally, certain inconsistencies when annotating words that correspond to the field of health without actually being a disease, such as to smoke and not smoking. In any case, these problems are only a small part of the dataset, and in our opinion, we believe that the creation of this dataset is a pioneering step for NLP advance in the medical field in Spain. The results of our system, both the transformer model and the hybrid option, are as follows. On the one hand, see first table, we have the results obtained in the validation set, while the second table represents the results obtained in the testing set. We would like to focus now in the first table. As we can see, our model has achieved excellent results in the overlapping evaluation and consistent results in the strict one. We believe that this large contrast may be due to our token classification approach. This approach is entirely dependent on the Roberta tokenization process, which has caused that, in many entities, only a part of the word will be annotated, and not the whole word. causing a lowering of the street result. Finally, we would like to highlight the conclusion of our paper. We have shown that our approach has obtained excellent results for both test sets of the SocialDisNER. We have performed a detailed analysis of the task and the dataset, and we have performed a comparison between a modern approach based on transformers with a classical approach based on a medical ontologist, discovering the limitation of both and finding that their combination has returned the best results. Thank you very much for your attention. For any question, we will be happy to answer you by the following mail. Best regards, Dezzai team. Thank you.